So, good morning, everyone. Thank you for coming. We'll talk about the GitHub Actions. This is not a complicated presentation, just an overview. I'm Sergey Khomutinin. I'm a software developer engineer. And the last 6 months I've been comparing GitHub Actions and comparing them to other CIs and Jenkins where I have experience. Why talk about GH Actions? Because this is an unusual tool from the classical point of view. If you compare it to Bamboo, there are huge advantages and disadvantages. What matters the most, this is quite simple. If you do GitHub, then through very simple actions you can tune all the process, and it's not going to cost you much either. So it takes just a little bit of time to tune up. We have to do a bit file and put it in the repository. No tuning, no need to fill out. What you need to do is get the proper extension. Also, the environment it helps a lot. We don't need DevOps because GitHub acts as DevOps. It tunes the environment, updates the environment, and we'll talk about that as well. Since we don't need DevOps, tester can tune the whole process, the test launch, with the help of GitHub. GitHub Actions are almost free of charge. They are completely free of charge sometimes. In the case of private project, you have 2,000 minutes. For GitHubs, for some mid-scale and smaller project, this is enough. In enterprise, if you have to pay for 3,000 minutes. So YAML programming, those are YAML files, so we will do the YAML programming, although it's a bit simpler than that. Let's first decide what terminology we use. Workflow, first of all. Workflow is a sequence of actions. In other CIs, it could be pipeline, but I think I know what you mean. You know what I mean. This is a sequence of certain units running in parallel or consequently, and we declare those in the YAML file. Every unit is a job, and we'll describe every job separately. And job will look like this. The 7 lines is sufficient for a GitHub action to run. Let's talk about it line by line. First 2 is a execution condition. They are connected to repository, so they quickly react to all the events taking place in repository. In the case of test, you will have just push. That's when the codes show up in this or that branch. We'll talk about events in more detail later. Won't talk about events in other slides, just to save space. And then in the jobs, we'll simply describe the jobs we'll do. Like the job build runs on. This is the key line. And this helps so much, and this saves you a lot of work. What we say is just give us something that looks like the Ubuntu, and it gives us a container, and then this is how it works. The Ubuntu latest is the container. The actions in our project will be running in this container. We can use many other operational systems, macOS, Windows that have different tariffs, and there are many other links as well. And Ubuntu latest, we have number 20. Number 22 is also available. So if we want to tune the test launch, we don't need to think about Ubuntu stable, unstable, so what kind of soft. It really doesn't matter because it's going to be stable. Because the GitHub is responsible, it updates and takes care of security.
Besides, we don't have to think about the status of container because it is only launched once per job. It's launched empty and then it gets deleted. We're not worried at all about any data trace we left. And steps to be completed within a container are fairly simple. The simplest way is to do a bash line. We could launch a code on Python or in any other coding language. So let's look at a more realistic case. We announce job test. It's launched on Ubuntu latest. In Python, first we need to identify repository, launch or install a Python to run our tests on, and that's it. We can start launching tests, start running tests, and do reporting. These 4 steps are all that it takes. Please note that we use users directive as a step. This directive launches actions themselves. This is a key feature of GitHub Actions, is that we can use communities and GitHubs we created by actions. In other words, let's use actions/checkout. In the checkout repository, it helps you check out our current repository. And we don't need to think about whether our repository is private or access key is required. We're not worried about it at all. It's GitHub's job. And it has all access keys, even if it's private. Step number 2 is action comprised in the GitHub set, which is installation by Python. Python installation is pretty straightforward, but there can be some peculiarities to it. This action is going to address installation of Python relevant to our tasks. We don't have to think or worry about Python install. We can use Python 3.10 because it seems to be pretty stable by now. These simple lines are push calls that every Python developer is aware of, and they are self-explanatory. Based on this, job will be executed, generating a report. It doesn't matter what the content here is. What matters is that we can click each line to invoke data, and if there are any errors, we will be able to see them. The workflow itself can be built in different ways. It could be done consecutively or simultaneously. In GitHub job, all actions are done in parallel because they are supposed to be interdependent. So before we launch our 1500 tests, let's make sure our basic functionality is A-OK. So let's separate a few tests as top priority, mark them, and before running 1500 tests, we will first run a sample tests to check the functionality to avoid any redundant work. To do this, we order a group of tests to be run, and the first job stays the same, but then we get the second job where we write needs directory, and within this directory we provide the name of the first job and the second job as linked to the first job. So this linkage has to be identified. And this is how the sequence is going to look like. We can also run our tests in parallel. In case of GitHub, all these containers provided by it with different operational systems are not super productive. They have 7G memory, and it's a bit hard to run those in parallel due to production constraints. But we could split them up by topic, for example, for integration or for desktop, and run them separately. So we can copy-paste similar jobs and indicate a set of tests that we want to run. And then we single out a particular group of tests, and in the end we will have 4 job sets that we want to run simultaneously. So for each launch there will be a separate container in GitHub Actions, and inside that there will be separate tests depending on our group. Why is this mechanics called matrix in GitHub? That's because if there are other parameters involved, there will be multiplication of all parameters, one by the other, and it will be a 2D or 3D matrix, depending on the number of parameters. So it's a classical parameterization, depending on your framework. It's also handy to run it in different environments. Now let's talk about events that GitHub provides. So we can run our test twice a day by requesting runtime at 5 o'clock, for example. So our tests will be run with no reporting. It'll be a job with its results in a full list. We can use a by button function where we can indicate input, like we do in classical Jenkins. We could use Suite for launching those tests. And this launch is going to look like this. We will use this button run overflow, run workflow. We could also use a pull request. This is most commonly used event, and these tests will be launched in any open repository which is active. So we open up pull request, and if it opens in draft, then those tests are not run. because request is not complete. If there are some changes made to pull request, a new code came in, for example, then tests will be launched anyway. If pull request is created in Veco master, then we launch the test. There are various filter options. In fact, if an application code has been modified, for example, in ABB, for example, then tests will be launched automatically. Reporting is another key part in any process. It's pretty bad at GitHub, like in any other system. The best thing we could do is try and write something in the console using special directives. Two columns, for example. So we can, in simple terms, create a group which could be hidden in Podcat, or we could write various info messages with different levels, kind of like debug or warning. Or we could write GitHub staff summary. This is a markdown filing which will show the results of our run. This is how it's going to look. On top we have annotations with different logging levels, and at the bottom markdown text which could be framed as a nicely written summary. Doing it manually is a tough job, which I don't recommend, but there is a number of tools that can do it for you. For example, in PyTest, there is a plugin capable of writing such annotations. It says, your test has failed in this file at this line. So on this pull request, you're going to get a message in the line where failure has occurred. There are similar plugins for a variety of languages. They come out of the box, and this reporter comes out of the box, and you need to indicate that. A lot of frameworks are represented as HTML reports, and they come in as artifacts, which is not very convenient. We're going to have it as a file which can be downloaded locally. For some scripts, it works. We'd be better off locating a ready-to-use action which will help you blend GitHub action with other GitHub product, like GitHub Pages, for example. So GitHub Pages helps you put in server some code which is easily viewable on your screen. For example, a Lua report which provides history action. I don't suggest writing that logic on your own, but looking for it somewhere, searching for it somewhere is certainly a possibility. You could also rely on external system. There are a lot of them around. Let's cover some community-related actions, because community is robust and well developed in GitHub. There's, for example, Superlinter, which is developed by GitHub. This is a super aggregator which is connected by 5 lines, and it's going to lint everything. It will tell you what files you have, JavaScript, Python, and it will launch files in those scripts which are available.
So GitHub is responsible for linter launch, but those are the things that you can do on a daily basis. Another good thing is Markdown file. So this is a test reporter. This can handle flow work reports, and it makes such a beautiful tables. You can take a look at it. The GUnit, Jest, all are supported, some of the others as well. There are quite a few of them, and a couple of console stars, and like a separate lint which can lint actions. The YAML file should not be corrupt, and this makes sure it isn't. And act. This is something that GitHub that launches GitHub Action. It works, but there are some issues about it. You can run it if you wish. Of course, we can write our own GitHub Actions simply to reduce the code we have in projects. Composite action could be an option as well. The workflow becomes a separate action, and then it can run just in a single line. And we don't have to use the shell in such action. We can use any shell we want, Python or JavaScript, basically anything we want. So to launch such an action, you might need some different environment. Then you can make a Docker image, and that's where you can launch the action from. And that will work automatically. And the last thing I'd like to talk to you about, security things. So GitHub Actions are quite simple, but they're not free. And sometimes some adversaries can butt in. There are lots of manuals about GitHub Actions. Actions can run a private environment. You might have some security things you don't need to trust. Fork repository, because any tester can view it, and you should not trust the community actions, even those that I described previously, because they can get access to your code, to your secrets, should you be transferring any. And thirdly, you need to be fully aware of some of the data you don't trust in the workflow, and I'll give you some examples. I'll also talk about GitHub token. Those are the tokens that help do all the action in the GitHub without the private key. So if this token runs away, then you can do anything you want. You can make issues, and you can do lots of bad pushes, and so on. Lots of difficult things to handle. Actions on forked repos, by default, they are banned. For example, you have an open source project and someone works on fork. For nothing, no actions will run. You need to manually make sure that no one is stealing your secrets, and then you have to approve that launch manually. I'm saying this, hopefully you won't be tempted to allow action launch for all the forks. You should not be doing that. Second thing is untrusted actions. When you use actions from the community, this is the way you should be looking at them. This could be a hacker's actions, a hacker that wants to steal your secrets, and those are your card data, banking card, and maybe your passwords and your mother's maiden last name. So think about untrusted actions. Maybe there is no malware code here, but tomorrow suddenly a malware code may show up, and this code will transfer your data elsewhere, and your passwords will be gone. To avoid this, what can we do? We can fork this repository in GitHub. We can copy them and to use your own repository. And we can copy the code from the section, put it in our own repository, and run it locally. So the fact that we indicate a concrete text, it doesn't run. Any code can show up under that tag. Now inputs. I showed you that there are inputs coming from users. Those inputs might consider on-screen code that can break down the echo line, like semicolon, and then anything command can run in this context, so we can steal any secrets, GitHub token. Basically, there are lots of techniques used to avoid it, not to use input directly, for example, but to use them with the help of changing environment. That would be a way of screening your actions and put all of them in the console. And inputs are not just what comes from users. Inputs are a lot of things. All issues, descriptions, title issue, requests, those that commit, messages, and sometimes author's email could also be there. This is untrusted data, and you should be making sure that this is going to be secure. So basically, this is how those two teams work. So we would choose this line, and this would tell us that you've been hacked. Second one is safe. Now, last one. Let's talk about GitHub token permissions. By default, with the help of this token, GitHub has full access to a repository, edit anything, make issues, adjust codes in all the branches except private branches. But if you're paranoid, then you can disallow all of those, and you can only allow it to read files in the repository, nothing else. But if we are to reduce the rehab token rights, then in the action we need to list the rights that it truly needs. If someone steals the token he steals will not have the full list of rights. Therefore, this will block some of the destruction he may cause. So those are security issues that are quite important that should help you keep your data. This ends my presentation. All examples are available on GitHub. You can scan this QR code. It's quite a history of launch. This is it. Use GitHub Action to build CR. Thank you very much for your attention. Thank you. I think we have questions. I thank you for your presentation. Dumb questions. You said that you can choose tests separately. Let's imagine this. I have a repository with 10 tests, and today I want to run test number 1, tomorrow I want to run test number 5. Should I be using YAML, adjusting YAML file? No. If you're talking about a button, you can just indicate the line that can be introduced. Like I want to test number 1 and number 5. So I just push the button and it says pick this or that. It's not going to do that. But basically, you will see a line and you can introduce anything, any untrusted input. Thank you. Second question about alerting. I too Chrome and runs every hour, and I want to be notified in the Telegram. But this can also run with the help of other actions. There's so many of them. Well, there are actions just in a couple of lines that would give you alerts. Thank you. But those are actions, could be actions that belong to a different hacker that wants to a bit paranoid. Thank you for your presentation. So if you're to tune with the help of integration files, devstand or whatever, you want to try GitHub Actions, but sometimes they're flake tests. They're difficult to seize. Sometimes you would waste a day or two, and then you would put a breakpoint on the wait list, and then you would debug on the stage. And I'm trying to reproduce it, and it takes a lot of time. How about GitHub Actions? The entire environment emerges later, and it's not an option, but you said when you are launching it locally, but it doesn't run so smoothly. So for such cases, GitHub is not that much useful. Well, you can choose an alternative. Yes, containers are down after the run, but you need a state, and then you can debug manually. If it's just a state, it can be attached as a file. Or not the GitHub runners can be used, but self-hosted node can be used. That's the kind used in the network, and then you can use self-hosted node if you support it yourself. And of course, there's a difficulty about it, but this becomes free, and you don't have to pay for actions. Thank you. Any other questions? Thank you for your presentations. You showed how the Python tests run and how the dependencies are set. It takes quite a while each time on GS. Can you cache it? Sure. All such things can be implemented with the help of other actions. Action/cache, and it can work with cache just about everywhere. So you need to see the documentation. Just takes a few lines to use it, and yes, it is doable. Any other questions? Yes, please. Thank you for your presentation. In addition to the previous question, so if we had to talk the self-hosted nodes, I'm not sure I remember this. So is there a way to launch self-hosted nodes? I think you have to pay for it.
If my memory serves me right, a free-of-charge version can do this, but it has to be an entity, not your personal project. And my second question is, have you utilized this infrastructure for running tests lasting for days, or for tests generating large amounts of traffic, like loading tests? In fact, when it comes to loading tests, it's not a very good way to go, because these are not that strong. But for GitHub, there are new nodes announced with 32G memory, and I think they are able to sustain state. So you could try using those for pulling it off. But for loading tests, you better use your own personal node. Thank you. Terrific. Are there any other questions? Doesn't seem to be the case. Sergey, thank you very much for your talk. Don't forget to give your likes, and the best question gets you a t-shirt. Who is that lucky